In this video, we're going to take a little different perspective on frequency distributions and histograms. So if you watch the previous video, we took raw data and we created a histogram and a frequency distribution from the raw data. But the question can go the other way as well. So in other words, we can give you a histogram and we can then ask you questions about what you see. And so that's what we're going to do here. We're going to use number 10, which you can see on the screen in front of you. It says car sales. A car salesman records the number of cars he sold each week for the past year. The following frequency histogram shows the results. And so we want you to notice the number of cars sold is on the horizontal axis, and the frequency, the number of times that occurred, is shown on the vertical axis. Part A is asking, what is the most frequent number of cars sold in a week? And so what they're really asking is, what is the frequency that's associated with the tallest bar in histogram? So you notice that the tallest bar is this one right here in the middle, and the frequency associated with that is 4. So the most frequent number of cars sold in a week would be 4 cars. Part B is asking, for how many weeks were 2 cars sold? So in other words, they're asking you to look at the bar for 2 cars, and they want to know how high is that bar. Well, you can see that it's 9 units high. Frequency is 9. And so 2 cars were sold for 9 weeks. Part C is asking, determine the percentage of time that 2 cars were sold. So before you can answer that, you have to know the total number of frequencies. So in other words, you have to add up the heights of each of the bars. And so you can use your calculator for that. You'll notice that the first bar is at a height of 4, and then 2, and then 9, and then 8, and so on. So you're taking 4 plus 2 plus 9 plus 8, and so on. If you do it correctly, you should obtain a total of 52 cars, or 52. And that makes sense because in a year there are 52 weeks. But in any case, if you want to calculate the percentage, you're going to need your calculator for that. Or at least it would be my preference to use my calculator. So anyway, as you can see, I have the tally there, and the frequencies total 52, as I said. And we want to calculate 9 over 52 as a percentage. So 9 divided by 52 gives us 0.17307 blah blah blah. As a proportion, that would be, probably 0.173 would be sufficient, or 0.1731. As a percentage, they're asking you to convert that to, they're asking you to get rid of the denominator, if you will. So, in other words, you want to multiply by 100, and you end up with what I would probably render as 17.31%. I'll take it just a second to mention this. In statistics, at least in my experience, a lot of people come into the class, and a lot of people have a heavy hand when it comes to rounding. And so we do have certain rules that we follow when it comes to rounding in certain circumstances in this class, and we'll talk about that. But generally speaking, a lot of people are very harsh when it comes to rounding, and so I would encourage you, in statistics, you want to relax a little bit about that. And so if you look at the problem here, in part C, it doesn't explicitly say how to round that. And so I would try to err on the side of caution there, and I would probably render it, to a couple of places at least. Let the reader decide if they want to round it. So in other words, I would answer that as 17.31%, and I would be very comfortable doing that. More than that, yeah, I could live with it, but less than that, is that's kind of harsh. So relax when it comes to the rounding. Let's look at the last part here. Part D says, describe the shape of the distribution. Now that may seem like a vague question, but it's actually specific, because Sullivan, the author, is expecting that you've looked at and have processed a particular figure in the text. Let me remind you of that. The figure in question is visible here. It's figure 15. And so for the purpose of describing distributions, what we're saying in effect is that we have these 4 templates. And so we're asking, which of these does this distribution that we were just looking at, the one for the car sales, which one does it best resemble? And I would say, well, if you look at it again, it looks like it's skewed slightly right, because it has a tail that runs off to the right side, just like part C of this figure has. And so if you want to confirm that, I would say I think that's a fair description. Now this is a little bit of a judgment call, so some people might look at that and say, well, it's kind of bell-shaped. And to be direct, this is not some vitally important question. I mean, it's sort of a general thing. And so if you're looking at this graph here on the other side, the one for number 7, I would say, well, that one's definitely skewed right. The one we have for number 10, I would probably describe it as skewed right because of the presence of the tail, running out there to the right side. But, someone else might look at that and say it's approximately bell-shaped. It's 6 of one, half a dozen of another. So, just for clarity, here's my answers to the various parts. Again, for part A, 4 cars per week was the most frequently occurring value. 9 weeks was the number of weeks that 2 cars were sold. 9 over 52 as a percentage would be 17.31%, and I'm describing the distribution, part D, as being skewed slightly to the right-hand side, RHS being an abbreviation for right-hand side. And one other thing that I would mention very briefly, we have a rule in our class that we try to follow when it comes to showing work. And so you'll notice that I did put down a few details of the calculation in part C. We do know that you have a calculator, and certainly you're allowed to use it, but we need to have some kind of a paper trail of whatever work that you did. And so that's kind of one of those things you have to start, even on the simple questions, doing, because what ends up happening later is that for more complicated questions, people end up trying to cut corners too much, and they end up losing credit on that. So we're very much in favor of you showing your work carefully and clearly so that you have a nice paper trail. Maximize your partial credit in case you make some kind of a mistake. Let's look at another example real briefly here. One other question that comes up in connection with a histogram like this is pertaining to the class width. So in the previous example with the car sales, it didn't really make sense to ask about that. But if we were to ask about it, here's an example on the screen, number 11, where it would make more sense. So if you recall, when you have a frequency distribution, you calculate the class width by taking the difference of consecutive lower or consecutive upper class limits. And so here in part B, they are asking you to determine the class width. And so it's actually fairly straightforward here, because you can see that it's 10. If you take, for example, 70 minus 60, that's 10. 80 minus 70 is 10. 90 minus 80 is 10, and so on and so on and so on. So remember that when you calculate class width, you always take the difference between consecutive lower or consecutive upper class limits. Hope that helps. If you have any questions, please drop me a line. Otherwise, go on to the next video.